So yesterday, you guys counted, big kid style.
Nathan McDonald, please come to the office.
Yeah. Because if you're in grade 3 and you went in and you said, hey, how many ice cream can you have? You go, oh, I want 2, and then you lose count at about 10, right? Yeah, it's the counting principle. You can use multiplication when you get really, really big numbers. Okay, same kind of stuff. Give you a little formula. There's a strange word here. It's called permutation. This is number of arrangements. So why didn't they use the word arrangement? I don't know. Okay? Again, English is a stupid language. We have far too many words in it. A lot of them have multiple meanings with the same word. Some have the same meaning. Okay, I'm not getting into all the synonym stuff, but you know what I mean. Example. Jane is an interior designer.
The question about Tyler today was a bit long, but yeah. He wasn't even going yesterday. Yeah.
What? Jane is arranging. Oh, and it wasn't recorded either, so Tyler doesn't even really know what the heck's going on. I'll see if I can put that in later. Jane is arranging, but it was pretty straightforward, right?
Oh, yeah.
The questions? Okay. 3 ornaments, because that's what interior designers do on her table. And let's just use symbols. Okay, she's got one of those. She's got one of those. And she's got one of those. And she puts them in that order and says, no. And then she mixes them around and goes, no. Okay? How many different ways could she put these on the table? Anyone want to guess? More than 3, right? 9? Okay, good guess.
27.
27, bad guess. No, there's no right or wrong. It's a guess, fine. Okay, we don't know, right? Okay, 27 different ways. Okay, so, well, let's be systematic. I want to have a nice picture here so you can see what's going on. So she could, well, let's ask a question first here. How many ways can she arrange this? Okay, these 3 ornaments on the, I don't know, I said table, maybe it's on the fireplace mantle. I'm not even getting into spacing between the ornaments. They do that too, okay? You know, when you want to contrast colors and shapes and styles and whatever looks pretty. I could do that. And then, just like I have them here, I could do that. Okay? So, it's nice to be systematic, not just in math, but with anything in life. So you don't, it's easier to keep track. Right? So let's still have my star first. There's another way to arrange the last 2, right? Instead of putting square circle, I could go circle square. Are there any other arrangements I could have where the star is first? No. I have to include all 3 in case some of you are saying, well, let's take one away. No. I have to have all 3. That's it, right? Okay. Well, let's start with square first. I could have star next, and then circle. And hopefully you see there's another way I could arrange this. Circle, then star. Any other ways I could have a square first? That's it. Okay, what's my other choice? What other thing haven't I had first on the shelf? Circle, yeah. So circle, star, square. Circle, square, star. Anything else? If you're systematic, it's pretty easy to tell if you're done, right? Okay? Yeah, how else, what other arrangement could I possibly have between these 3 ornaments or shapes? That's it. Okay, 1, 2, 3, 4. There's 6 ways. she could arrange 3 ornaments, okay? And if this is, meals, courses of meals, if you got 3 choices, there's 6 ways you could eat it in whatever order. In this part of the world, usually dessert's last. But I hear they do this opposite in the UK. They do dessert first and have salad last. Has anyone heard this? Was I being told a story, or is this actually true? I don't know. Okay, that's it. So, there's 3 possibilities. So, I want to write this again. So once the first, because we know this, we kind of saw it, right? But we want to make a kind of a model so that we can make sense of maybe the next problem, which is going to be a lot harder. Once the first ornament is placed or chosen, how about chosen? The second has 2 remaining choices, right? So go back to the beginning here. I chose, well, let's pick star first. Once the first one's there, there's only 2 choices you can have for the other 2, okay? So once you take that 1 choice away, you've only got 2 spots left. And then, once the first 2 are chosen, or using wordage here, once the first 2 are arranged, the third has only 1 choice, right? There's only 1 spot left. This could be people. I have 3 people. How many different ways could they exit my room? Is that any different of a question? It's 6 ways. But once the first 2 people go out, well, the third guy, he's got to be third, right? That's the only choice. That's what I'm saying here. Okay, what if she has 7 ornaments? Do you want to model this one? I don't know because I haven't done it and I don't want to. But do you know how long that would take to draw pictures of this? Even if you were systematic, because you know how many choices there are here? Let's go here. Do you know how to do this one? Okay, I'm going to say this was 3. The first one had 3 choices, and then the second one had 2 choices, and then the third one only had 1 choice. That's what this says in words. What's 3 times 2 times 1? Okay, well, if I have 7 ornaments, that first ornament, it could be in the first spot, the second spot, the third spot, so on and so on, or the last spot, which is the 7th spot. The first ornament has 7 choices as to where I'm going to place it. Once it's placed in that spot, the next ornament, how many choices would I have for it? Good. Okay, because one of the spots has been taken. And so on, and so on, and so on. Okay? Once 6 ornaments are placed in their spots, the last guy only has 1 place to go. There's only 1 way I could arrange that. What's this? What's this number? You want to draw out 5,040 pictures? This is an art, and that would be a cruel course. It'll take you all semester. Okay? Okay, how do I put that in my calculator? What if I had 47? We're going to get numbers that big. Do you really want to go 47 times 46 times 45? Okay, do you want to do that, Tyler? Yeah. Let me show you a little shortcut. Ready, Ellie? Math. Button. See PRB? That stands for probability. Go over to it. You see that thing beside the 4? What do you call that in English? It's an exclamation mark, and actually I screwed up. I want to put in 7 first, then the math button, because you got to put in the number first. Probability, you can scroll down to number 4, or just hit number 4. What is 7 factorial? That's what that sign says. Yeah. See, people have lived before you guys, and they invented this because they didn't want to do 47 times 46 times 45. Okay? That was a waste of time. So they invented this little program. Okay? That's 5,040. There, learn something new every day, right, guys? There's a little button on your calculator. Okay, this is written as 7. That's called factorial. Okay? And if you forget how to do that, you hit the math. Well, first you hit 7, the math button. You scroll to, it's not a button, so I better not put it in the box. Probability, and then 4, and then enter. Okay? And you get the same number. Okay, fun little button. Yeah, I thought you'd think so.
It's pretty neat, actually.
So, less words, more algebra. We can play around with some of this factorial stuff. Hold your enthusiasm. Save it for other classes, like socials. Okay, evaluate 8 factorial divided by 6 factorial. Do you want to do it the long way, or do you want a little shortcut? Because what does this mean again? That's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or you can just put it on your calculator, but let's understand what's actually going on here. That's 8 times every number less than it down to 1. This is 6 times every number less than it down to 1, right? Can I cancel some stuff here? Everything on the top's multiplied, everything on the bottom's multiplied. What's 6 divided by 6? Get rid of it. What's 5 divided by 5? 4s, 3s, 2s, 1s. All that is 56. Right? Because you could also think of that as 8 times 7 times 6 factorial over 6 factorial. And that's the same number. So you can just cancel that thing out. Okay? So I know you could probably put that in your calculator, 8, scroll over, but you know what? Someone with some good understanding would already be done, okay, by the time you do this. And you're not always going to get ones with numbers. They're going to have some variables in there, okay? So you got to understand this. Same thing. Okay, 8 times 7, whoop, that's 56. Make sense? Simplify. This one you can't put in your calculator. N plus 1 factorial over n factorial. Do you know what n is? No, because I haven't told you. Okay? Might be 40, might be 6, might be 212. But again, what does this mean? 8 factorial, I'm multiplying 8 times every number less than it, okay, down to 1. So n plus 1, there's the number. What's 1 less than n plus 1? Right? N plus 1 minus 1, that's just n. That's 1 less than it. Okay? Make sense? No? Okay. 8 factorial. I'm going to go 8. That's the number I start with. 7 is 1 less than this. Okay, okay. N plus 1. There's the number. It's not 8. It's n plus 1. What's 1 less than n plus 1? What's n plus 1 minus 1? Yeah. What's 1 less than n? N minus 1. What's 1 less than that? N minus 2. Whatever n is, it's going to go down to 3, 2, 1. Okay? I just don't know what n is. Okay? Let's say n was 7. What's 7 plus 1? Okay? 7 times 7 times 7 minus 1. It's the same thing, isn't it? 7 minus 2, so on and so on. At some point, whatever n is, even if it's a billion, at some point it's going to go down to 3, 2, 1. That's the top. On the bottom I have n times, what's 1 less than n? N minus 1. Do we see like a pattern here? Do I need to write any more? These are all the same numbers. Something divided by itself is 1, okay? This all cancels. So what my answer is just n plus 1. Irregardless of what n is. I didn't tell you what it is, okay? And you don't care. This simplified is n plus 1. Okay? So in general, for factorial, because it doesn't always have to be a number, n factorial is n times one number less than it. Okay? Well, 3, those should be times, right? 3 times 2 times 1. Okay, that one doesn't say evaluate because you don't know what n is. Let's look at another. Does it have an equal sign? Yes, it does. That means it's an equation, we can evaluate it. Okay, well, I don't know if anybody can look at that and do it in their head, maybe after about 20 practice questions if you're really good at this kind of stuff. So what can you do? Well, we're just going to work this thing a bit, all right? I know that n minus 3, okay, what's 1 less than that? N minus 3 minus 1, right? N minus 5, and so on and so on. N minus 2 is n minus 2. What's 1 less than minus 2? N minus 3. 1 less than that. Do I need to keep going? And that equals 4. See some stuff that I can cancel out here? Yeah, whatever all this stuff is, it cancels, right? N minus 4, n minus 3. Okay, well, that looks a little nicer. What do I have left on the top here? Everything canceled out, but don't say nothing. You got to put a 1 there, right? Otherwise, what's on top? You can't put a 0 there. So 1 over n minus 2 is 4. How do I solve that thing for n? You like cross multiplying? Okay, that's one way. Let's say that's over 1, right? This times this equals that times that. Just make sure you put brackets there, otherwise it's wrong. Okay? Now no more fractions, because people don't like fractions, right? So the other way of thinking about this is, well, I want n by itself. I don't like this stuff down here. Let's get this to the top. Let's multiply both sides by n minus 2. Okay, that divided by itself is gone, and I end up with the exact same thing, don't I? 1 is 4 times n minus 2. So whatever way you want to think about it, algebra rules or cross multiply, either's fine. All right, so 1 times 1 is 4n minus 8. Add 8 to both sides. This is grade 8 math, right, guys? So don't be all, okay. 8 and 1 is 9. Is 4n. Second step, let's divide that 4 away. N is 9/4. If you saw what that was right at the beginning, then, well, you're better than me, okay? One more. Because without this one, I don't know if you'll remember how to do this. Okay. What's our first step here? You got a couple choices, actually. Do you just want to see what that factorial stuff is? Get rid of that exclamation mark? Okay. Okay, 3 times n plus 1. What's the next thing? What's this minus 1? N, right? We'll keep going until you get the same thing on the denominator, because all the rest of it's going to cancel, right? All the way down to 3 times 2 times 1, but I'm not going to write it. Okay? This all equals 126. Okay? All the rest of that stuff, all the way down to 1, is going to cancel out, because I got the same thing on the top and the bottom. Okay? So what do I got left? I got a 3 times an n plus 1 times an n is 126. What do we want to do next? What would make my life nicer, easier? I could, yeah, I could multiply all that out. I might want to do something else first. Can I get rid of the 3? Could I divide both sides by 3? Does that go into 126 nicely, Brittany? How many times?
42.
Yeah, so let's get rid of it. That would be one less thing to multiply everything out. Okay. I could have done that right at the very beginning. Okay. Some people see that, some people don't. Doesn't matter. But I probably want to get rid of it before I multiply it out. I could have done it here. Okay, that's fine. Now I have no choice. Yeah, I got to multiply this out. So this is times everything. N squared plus n is 42. Now it's starting to look like some grade 10 math, grade 11. Either one, pre-calculus, you did a little more of this, but we still did it in foundations. Okay? So what do you want to do here? How do you solve that? That's what it says. What squared plus what is 42? And some people can kind of do that in their head. I wouldn't recommend it. Trial and error. Let's try 5. 25 and 5, is that 42? No, it's not, right? We want to solve this thing. I want this thing equal to 0. Okay, so let's subtract 42 to both sides. That's called a trinomial. When is that thing equal to 0? i.e., can I factor it? Okay, I hope so. And if not, well, you know, this will be a question that you're not going to get in the test. And it's not going to be half the test, but at least one question, maybe 2. Okay, got to remember this stuff. This is grade 12 math. So, how do you get to n squared? What times what is n squared? That's got to be n times n. Okay? And then what multiplies to negative 42 and adds to the middle number, which is a 1. What 2 numbers? Bingo. 6 and 7, but I got a negative. So where does my negative go? Let's erase this stuff. It's a plus n, so yeah, I want the plus here so that it's bigger, so that when they add, okay, it works out. So I want plus 7 minus 6, and then let's check it. Okay, this is what we're doing in grade 10 right now, polynomials, right? FOIL, n times n is n squared. Outside, minus 6n. Inside, plus 7n. Last is minus 42. That is, in fact, what I got. Okay, so I know I did this thing right. Okay, so that's easier to see when this thing is 0. We did a lot of this in pre-calc, not so much in foundations. When is this thing equal to 0? What value of n? Negative 7, because if that's minus 7 plus 7, that's 0. And 0 times anything is equal to 0. Okay, but I got another choice here. When is this thing equal to 0? When n is? Yeah. Because when that thing is equal to 0, 0 times anything, this equation works. Okay? That's my only 2 values of n where this thing is going to work. Right? Check it. Negative 7 squared is 49. Positive, right? Plus negative 7 is positive 42. And if I put 6 in there, what's 36 and 6? 42. They work. There's just one thing we need to consider. There is no negative factorials. Okay? Negative anything, but negative 7 factorial has no meaning. Okay? So, no negative factorials. Okay? Because how's it ever going to get to 0 if you start at a negative and subtract 1? It won't. Right? It's perpetual, infinite. Doesn't make any sense. No negative factorial, so I have to reject that one. Remember rejecting stuff, Shelley, in Math 11? Huh? Rejecting things in Math 11? No, like your test marks. Yeah, okay, so that's your only answer. Okay? No negative factorial. Okay, what's the page number? 4.2. Page 243. 1 to 12. Looks like a lot, but they should be pretty quick. Okay?